Actually, I was going to have Matt. Matt, why don't you come on up and introduce yourself? Then I'll reintroduce myself, and we'll go from there. Okay, responsive game design. So like I said, at a high level, I wanted to start off the gaming track by talking about, like, as developers, I was saying it earlier. I mean, I assume most people are here for the morning stuff, right? Like, I would love to tell everyone just publish at Amazon and then all your answers will be solved, but that's not the real world, right? The real world is that even if you were on iOS, you still have to think about every platform possible because the best place to get reach is to go where customers are, and that's wherever they are. So that being said, a lot of my time really focuses on how do I build a game that scales correctly across all different types of devices, screen sizes, resolutions, and all that stuff. And that's sort of what responsive game design is, and I'm going to talk about that in a little bit more detail. So I gave like a high-level intro. Again, if you missed it from this morning, I'm a developer evangelist, so my job really is to work with game developers around the world. So where my job ends is once you publish to the store. Promotions, stuff like that, that's when you talk with Matt and someone who's on our biz dev team, and that's where you get more support about how do you build and grow your app. As far as my background goes, so I'll go into this a little bit more detail now so I don't have to do this at every talk. I'm from New York. For years, I did agency, enterprise. I've worked for government. I did a lot of web-based stuff. So I've designed everything from name a music artist. I've probably done their website, Pink, Khalees, Outkast, Usher, to HBO.com. Built HBO.com, built their first Android app. Done enterprise for Bloomberg. Also bank, back-end software. It really is not fun. And throughout all of that time, I've always loved making games, but the reality of being a game developer, I'm sure it's the same thing here in London, being an independent game developer and living in New York is basically impossible. It was like one step above. My background's in art, and my parents were like, you're going to be like a starving artist living in the East Village. And I did live in the East Village, but I wasn't a starving artist because I did web development. Throughout all of these jobs that I've had, I've always snuck game development into it. And I think that's one of the most important things is that you don't always get to do what you want, but you can at least have a little bit of that passion into what you do day to day. So HBO.com is the perfect example. I had to build this schedule for HBO.com, and the schedule had to show all these different shows, and it had to parse all this data. And the engine was actually a game engine I used. I wrote a Mario-based like tile engine to show all the data and blid it to the screen so it was super fast. And no one had ever seen anything like that. And like, how did you get it to run so fast? I go, because I made a game engine. Like, I know graphics, and I did this how I would build a game. Same thing is applied. So all these enterprise apps I built, I use games. And the irony is that everything I've learned through that also applies back to games. So some developers I work with, I have a leg up because I have years of enterprise. So I'm very organized. I do version control. I know how to work in teams. I know how to scale very well, and I know performance optimization that most people don't do because they don't deal with, when you work at like something like Major League Baseball, I built our draft tracker, and our draft tracker is used by millions of people, and it has to have concurrent data. It was used on ESPN Live. The teams are using it, and it's a huge app, and you don't know scalability until you're working in millions and millions of concurrent views. So all that being said, the goal even back then was, build one website, work on multiple browsers, and now today is build once, and how do you get that onto multiple devices? So for mobile developers, supporting all of this stuff can be a challenge, right? Like just Android alone, I remember when I was building the Android app for HBO, there were so many resolutions, so many devices. Like literally, we had to go in and manually blacklist devices we knew just didn't have the memory to run the app. And that was a native app, all right? And this was the early days of Android. So just dealing with just Android alone, our platform, we strive really hard to make sure that all the devices are consistent across the board. I'll talk about our resolutions in a little bit, but we try to make sure that each generation has very similar specs. Obviously, there's a little bit of a difference between the higher-end tablets and the lower-end tablets. Like our 50 pounds here, $50 Fire tablet is going to have a little bit lower-end specs than the higher-end tablet, right? But at the same time, we try to make sure that everything is consistent across the board. So when we talk about resolution, this is usually like the biggest thing that we think about, right? Is how do we get a game to look right on multiple resolutions? So we look at just our subset of devices. Up here we have the Fire HD 6, 8, and 10s. So these are our main tablets that we're selling now. They're all an aspect ratio of 8 by 5. And I sort of touched on this morning, and I'll go a little bit more deeper into it, but I always look at aspect ratios. I never look at resolution. Resolution is irrelevant because there's so many different resolutions out there, but general aspect ratios are important. Then if you look at our Fire TV Stick, it's going to be a 16 by 9 aspect ratio. If you're on iOS and it's an iPad, it's going to be a 4 by 3, right? So you have all these sort of different ranges, but you see ours are pretty close. In our Fire, the 50-pound device is going to be, it's close to 16 by 9. It's something like really weird, like it's a little, like when I did the aspect calculator, I'm like, it looks really weird. We'll just say close to 16 by 9. But the idea is that once you get within these two ranges, especially if you're trying to support like iOS, for example, and the 4 by 3 aspect ratio, they'll all scale correctly across that. Now, the challenges that you guys face on normal Android devices, such as all these different devices and screen resolutions, we actually have a very similar issue that developers have to look into, because not only does our App Store run on our devices, but we actually allow you to install App Store on any Android phone. And a lot of phones have it pre-installed too. So Samsung phones have our App Store pre-installed. And from our App Store, you can basically buy diapers and video games, right? Like physical and digital games. So we're really an A to Z store. Our dev portal allows you to target all Android phones as well. So here I just have like a list of, it's like 230 plus devices that our App Store runs on and that you as a developer can also reach as an added audience. Also BlackBerry as well, we're the default store for that. So even just building for our App Store, while of course we have 4 main tablets right now and 2 TV-based streaming boxes, and then we have several generations previous, we also support a much wider Android ecosystem. And then the reason I really like I was saying earlier when I was talking about Fire TV, like what really got me into this is that I just love building games for the TV. So the fact that I'm able to take mobile games and also get them to run on the TV with Fire TV has been a really big, incentive for me to like sit down and really try to figure this out. Because there's a huge difference going from a desktop to a mobile device to a TV. All 3 form factors are treated completely different. Their inputs are completely different, and the user interaction is completely different as well. So I use this quote a lot. I made sure, I think I took it out of the other slides. The other talks is that talent is cheaper than table salt, and what separates talented individuals from successful ones is a lot of hard work. And if you go back and you look at all these successful game companies, right, like indie success darlings, right, Rovio and stuff like that, you're all like, well, it's easy. They just made, Angry Birds, and they're a huge hit. But those companies had a bunch of games before they actually made their hit game, right? So a lot of developers I talk to, they make a game, they release it, and no one notices, and then they're like, I'm done with this. This is terrible. And I'm like, well, okay, try again, because you have to keep working at it. So my suggestion to you, though, is that as far as supporting all these different devices, it shouldn't be hard work. You shouldn't really have to struggle at it. If you think about your game from the ground up and build in these concepts systemically into your development process, you won't have to worry about a lot of the little details of like, oh, we got it on a new device, and all of a sudden, everything, all the aspect ratios is completely off because we didn't think about supporting that. Where you'll always have to optimize is going to be performance between devices, and that I can't help you with. But as far as designing a game that works across all of them, we're going to sort of dive into that right now. So what is responsive game design? So, are you guys familiar with responsive design from the web, right? Like, the concept of it basically just allows us to take a desktop website and put it into a mobile form factor. So, actually, before I even skip that, so like in the early days, if you think back, everyone had like mobile dot whatever their domain was, because nobody knew how to treat these websites as a one-size-fits-all solution. So, in order to do that, what they wound up coming up with was it was just too expensive to build a specific site for a type of device. So that's when they came up with responsive design. And all the idea behind responsive design is that you box off your content into groups, and then depending on the device, you either expand the group out or you stack the groups horizontally. And it works really well in web because in web you have CSS, so all of your front end and markup language can automatically just shift and respond to whatever the design is. In games, we don't have that luxury. There is no like universal markup language that we can use to make things easier to lay out. So I started coining this phrase, responsive game design, and as much as I've tried, you can't coin your own phrase on Wikipedia. I've tried, it doesn't let you. So I'm making it official, and I've talked about it for the past year and a half. So it's as official of an industry term as it's going to get. But the idea really is, how do we take all these similar concepts from web and then also apply them to our own game design? So in order to sum up what responsive game design is, I came up with 4 tenets that you need to consider when you're designing out your game. The first is going to be the game graphics and UI need to support multiple resolutions. Right, this is the given. Right, at the end of the day, your game just needs to look right on every single monitor. Also, and number 2 is that the game mechanics need to work across multiple types of input. Like I was saying, how you interact with a TV, how you interact with a computer, and how you interact with a phone or a tablet is way different from each other, right? There are some overlaps. I should probably do a Venn diagram of a computer is very similar to a TV, and a mobile can maybe have a little piece of it. But all that being said, it's how do you simplify your game to work across all these devices? Also, how do we publish to multiple platforms with the same code base? This is probably, if you come from console development or have any history in that kind of stuff, it used to be you'd literally port and rewrite the whole game to a whole different platform. Now we have cross-platform frameworks that we'll talk a little bit about throughout the course of each of these talks today. And the idea behind that is now as individual, this is why individual game developers can exist today. You couldn't do this as an individual before. Now anyone can go and build a game in Unity and have it on 17 different devices, right? That just wasn't possible before. And then the fourth one, which is the most important of all this, is saving data and syncing your data across all these devices. Once you get a game that runs across different devices, different form factors, and different OSs, like I was saying earlier, don't punish your customers if they buy your game. We live in these households where people may have a Fire tablet at home, and then they use an iPhone, or maybe their spouse uses an Android phone, and you have all these multiple phones, right? But they want to play the game and have that data transfer with them, right? So we'll talk a little bit about some solutions for how to do that. But then altogether, these are the basic rules that allow you to build a game that goes across different devices. So let's talk about graphics and UI. So scaling visuals across different resolutions. So what does it take to get a game's graphic to look good at all these different resolutions? And the example I use is, how many people ever played Civilization, the original Civilization on DOS? So I was a Mac person, so I didn't have Civilization at first. And I remember when they ported Civilization over. If you're not familiar with Civilization, it's the great grandfather of strategy games, right? It's the birth of the 4E, right? It's Explore. No, 4Xs, right? It's Explore. I forget what it is. What are the? Do you know the 4Xs? I should. It's saying Explore, Conquer, something like that. Anyways, it's these 4 tiers of how you play a game. You're supposed to build resources and all this kind of stuff. That being said, I remember when they ported it over to the Mac, they didn't take into account really that the resolution on Macs were a lot higher than DOS computers at the time. So all the UI was super tiny, and you're like, what is this? On my 12-inch monitor, what does that say? So, you have to really understand that when you go from one resolution, especially now with mobile devices where some of them have really high DPI, you wind up with, you can't, the UI has to look consistent across the board. So, just like I did with enterprise and with web development and any other development I've ever done, I always build for the lowest common denominator, right? What is going to be the weakest link in your pipeline of deployments? Find that device. It's generally going to be in the mobile category, and design for that device. Once you find the lowest end and build up from there, then all the more powerful devices will work. You just need to start at the base. And a lot of people don't like that, because a lot of times when you start with a game, you're like, I want to have the best visuals ever. But then people are like, well, I want to have money. And in order to have money, people have to buy my game. And if only the 1% has the best devices, then you're going to wind up not having a good, huge fan base. So I designed for mobile first. As I was talking about, I hover between two different aspect ratios. I focus on 16 by 9, which handles all my wide screen aspect ratios, and then 4 by 3, which handles the iPad, and then also some of the earlier. And now I think even like Samsung's new tablets are going back to that aspect ratio. So like it covers this whole gamut. And then the 8 by 5 sits in between both of these resolutions. So this sort of like shows you kind of how this works. And I'm going to go through this example later on when I talk about the optimizing Unity later today. But I feel like kind of weird pointing this way, but I don't want to have to move the camera. Sorry, so I'm going to turn my back to you guys, and I'm really sorry. It's not rude, but you can enjoy my bald spot. So this game here, what I've done is this white outer box represents the camera in Unity. And so this is the camera. This outside line represents, it's very hard to see, but it represents Fire TV. So I've created these guides in my app that tell me, all right, well, what is my Fire TV resolution? It goes out to here. This line inside here, right next to the red, that represents the tablet resolution. That's an 8 by 5. So now I can see in one screen, what are my two aspect ratios? And I don't have to keep switching back and forth between them. And then the most important, right now, I'm sitting in between these two aspect ratios. On this inner aspect ratio, I have, since this is my lower resolution, my lower aspect ratio, the red represents the overscan that I was talking about earlier this morning. So anything that's touching that red, I know will not be able to be seen on TV. And anything green means it's safe. So what I do is I go through and I make sure that I design my UI and everything to sit in the lower aspect ratio. And so that if I go to a higher aspect ratio, it just stretches it out a little bit. But it doesn't alter it. And I always make sure that I'm not clipping anything off. So here's an example. It's going to be really hard to see, but I'll switch over to resolution. And what happens is that when I go from the two different aspect ratios, when I'm in the game itself, all I'm doing is extending the field of view. So it doesn't work in every game, but sometimes you get an unfair advantage by getting more pixels on either side. But in essence, I'm only adding like 30, maybe at worst 60 pixels to my game. So all I'm doing is between the two aspect ratios, I just stretch everything out and I see more. And that's sort of like at a low level, how do you handle is the most basic concept of dealing with different aspect ratios and stretching between UI. By the way, that took me like 3 years to master. Like I can show it to you in like 2 slides. But it took me like 3 years to really wrap my head around that concept. Because I don't think nobody really explains it to you like that, right? You see and the harder part, and maybe depending on the time when I do the Unity talk, I'll show some of the code. But like it's not very hard. I think one of the reasons that's attracted me to Unity is that I can have a 3D camera, so I can change the distance of the camera from the field of view, and because of that, I can always maintain the correct aspect ratio. And I can always make sure that, and I do talk about this later on, that when I have something that's 100 pixels by 100 pixels, and I'm on a bigger resolution, it needs to scale up to always maintain that aspect ratio. So game input, this is by far the most challenging of any of the tenets. And this is a good example why. So Gizmodo had this really great post on the evolution of the console controller. So everything going back all the way to Tandy to the Wii Arcade, which, I mean, basically to the 360, right? And again, this is a few years old, so we don't have, but nothing's really changed from PlayStation 4 and Xbox One to now. I think the only thing was I got my Steam controller in the mail the other day, and I took it out. I'm like, whoa, you're really weird and different. So I haven't yet wrapped my head around how to deal with a Steam controller, but it's not on the chart, so I'm just ignoring it for right now. So basically, what happened was in the evolution of this going back to like the Tandy, one stick, one button. Pretty simple, right? Then we get to Atari, same thing. And then we go to ColecoVision, and all right, we're starting to add something really weird, like a number pad. I have no idea why they added a number pad to the ColecoVision. Just made no sense, but whatever. It was another type of, I don't think any games really ever used it. right? Like, were there any games that really took advantage of the number pad? You just still use the one stick. But the point that I want to make is the number of buttons on the ColecoVision controller and the number of buttons on the Xbox 360 are almost the same. And what's happened is that through the evolution of game controllers, the ergonomics of the controller have allowed us to take something complex, like how do you deal with 10 plus buttons in your hand, and turn it into something that's manageable, right? So over time, we've been trained to deal with more complex interactions with the game controller. Then mobile comes along, and all you have is a touch screen. And now you have to simplify everything down to one touch, right? So it's like we're reverting back. In reality, though, supporting input across all these different devices, if you build the game from the ground up knowing these limitations, knowing that I want to be on touch and I want to be on desktop and I want to be on TV, you can simplify the controls. Like a lot of times we try to add as much control into a game as possible, but this is sort of where our heads are at now in the console space. But it doesn't mean that you need to use all 10 buttons. It's okay to, Crossy Roads works really great on the game controller. Like, it just has 4 directions, and that's it. Like, don't feel like just because you have everything, you have to use it. So I'll talk about this in a lot more detail when I talk about the Unity stuff later on. But at a high level, a game like this, which I was just showing off my Super Paper Monster Smasher, come on, it's a good name. It just really stinks when you want to show it in like the label and like on your like device. It's just too long, so I just truncated it. But anyways, I have 2 buttons. It's just you can move left and right, and as the monster moves back and forth, he just eats the people, and he just automatically eats people. And I've gone through and I've just simplified this because one, I made the game. Most of the games I make, I want my kids to play, and I have a 6-year-old and a 3-year-old. So, and I think I made this when my oldest was maybe around 3. So I want him to be able to play it and not, feel challenged. And 2, it's just, why add another button to eat? Why add another button to jump? So when you eat enough people, he automatically jumps and, kills the people around him. So I tried to make the controls as simple as possible. And then what I'll talk about later on is, what you see over here is this input manager is I actually take all the inputs and I abstract them into a common language that my game understands. So here I have a custom-built input manager, and I map that to the axis that you can use in Unity. And long story short is I don't know where input's coming from. It could be coming from touch. It could be coming from the keyboard. It could be coming from the mouse. All that gets funneled into my game, and all my game looks for is do I need to move right? Do I need to move left? And then I map that. So whatever input comes in, I write an adapter for it. So that means I could create, a power pad. Like the old Nintendo Power Mat. We had the buttons, and I can control the game with that. As long as I can figure out an interface into my game, the game will never know the difference. I just need to trigger, hey, we're getting the big red 1 button they jumped on, make the guy move left. So the other thing that's really important, and this comes up a lot with Fire TV games, is please detect the platform and show the right controls. There's nothing worse than loading up a TV game and seeing touch here in order to move the player. My 3-year-old would love that, but we don't want him touching the TV, right? That's not the correct interaction. So it's a small detail, but I've seen it happen so many times. And also, I like showing just what does the key or the button look like. Again, my 6-year-old can read now because he learned how to read from video games. But not everyone knows how to read, especially if you're building kids games and stuff, right? So show a picture of what the button is, especially with the color to it. Use visual cues because most times people just skip through this stuff anyways. And then also things to think about is how do we anticipate user navigation flow? So making sure that we're able to, when you're working on something like this, on touch it's not a big deal, right? But if you're working on a controller or keyboard, you need to be able to move up and down and left and right and have this flow. So when you're doing UI for TV, it's got to cycle through. Don't make someone go all the way down the continuum and be like, oh, wait, I want to quit the game, and then go all the way back up. If you go from the store down to buy, down to continue, up to quit, it'll just be one big cycle, right? So think of the user flow when it comes to controllers and simplifying that for people. So single code base, right? And I talked about this earlier. I mean, the real key to this and the way that this only works is that as individual developers, even bigger companies, they don't want to rewrite the plumbing every time they want to be on a new platform. So you need to make sure that you pick the right framework that's going to, one, work well for how you know how to code, and two, can get you to the platforms that you want to be at. So, I had a picture of like Unity up here, because Unity just has a really good visualization. It's hard to visualize that HTML5 can be on all these platforms. There's no like button to publish it like that. But Unity does a good job where you just go into the publish settings and you can just pick a platform you want to publish to. But in addition to Unity, HTML5 is a really good option for cross-platform development. We'll talk about that in the next talk of HTML5 versus Unity. GameMaker is a really good one as well. So maybe you're not a computer science whiz and you want something that's a little bit more drag and drop and you want to focus more on playing games, making games and not programming them. GameMaker is a really good solution. And some of my favorite games have been made with GameMaker, which completely shocks me every time I see it. I'm like, I like to rewrite engines from like scratch. So like every time I get into like something like GameMaker, I'm like, I don't want to drag the move behavior. I want to write the whole thing from scratch. So, but that's a good one. And Unreal Engine. Unreal Engine runs on all different platforms. They're like the higher end of the spectrum, right? They're high-end 3D. They only work on high-end hardware, but that's really more for like if you're going to console and high-end PC. They do support mobile, but it's still a cross-platform one. And if you want to build 3D games, it's a good solution. So, and again, just talking about like this is a game that I actually wrote in HTML5, and then I ported it over to Unity and rewrote it in Unity just to see the differences as I was doing it. And I had the game running on sort of everything. I just actually have to find some time when I'm not traveling to just hit the publish button on our store and get it into the store. I think the HTML5 version is live. So let's talk about syncing data. So this, again, is an important part of the process. Again, I'm not going to repeat it again. Like I have sort of like the same mantra, but just make sure that whatever your saved game data isn't locked to one specific device. And so, and I was saying earlier, like all of our devices in our family of devices support Game Circle, which is our built-in leaderboards achievement. Every user of a device gets a profile that's their gamer profile. And as they continue to play games, as developers, if you add achievements and unlock stuff, that follows them from device to device. It's powered by something we call Whisper Sync. So Whisper Sync, you may have heard from our Kindle devices. So the e-readers, basically it allows you to pick up a book anywhere on anytime you open a Kindle app, whether it's on a physical device, a tablet, your computer, it's all synced. We use a similar technology, and we make it available to developers. So it handles all the stuff that you don't want to deal with, like resolution conflict, fixing, whatever that magic thing is called. It just resolves any conflicts. And also, it saves offline so that when it goes back online, it adds to the cloud, and it syncs it up for you. And you can learn more. All this stuff is on our developer portal. But you just go to developer.amazon.com. And you'll see down on the side, you can go and learn more about Game Circle. The other end of it, though, is what happens when you have to deal with multiple OSs, right? So Game Circle works on Android devices as well as our store. iOS, it does not work on. So if you need to support, or even desktop, right? Or whatever new weird device is out. AWS is a service called Cognito. I've not used it that much, just enough to kind of understand the high level of it. So I'm no Cognito expert. But the basic idea of it is the same thing as what Game Circle is providing, but it's cross-platform, and you have to write a lot more of the glue to make it work, but it gives you a place to store data in the cloud and also access it and a way to link a profile. So the biggest part of this is if you're working on different devices and different OSs, you need someone to have a single profile in order to... you have to have a single profile in order to actually make this all work. So let's talk about like a real-world example. Has anyone heard of Terraria before? Right? It's a pretty popular game. If you've not played it, it's basically like a Minecraft-type exploration, building, collecting type of game. But it's 2D, which I like, and pixel art. Terraria really works well in this sort of responsive game design model because their modes of play are broken up into 3 different types of categories. So there's digging, where you explore the world. There's building, where you actually just create buildings and use the stuff that you've collected. And then there's fighting. And each of these lend themselves to a very particular style of play. And because of that, they work differently, and some of them work better on each platform than others. So let's just sort of skip ahead. We'll talk about digging, right? So digging is the most basic interaction you get in the game. The game started as a PC game, and then it started getting ported over to all these different platforms. And as you go through and explore the world, it actually works really well on touch. Like, I'm not a big virtual controller person. I was talking to somebody about this the other day. Like, just like the difference in 30 years between me and my son is that I grew up on Nintendo and physical game controllers. He's playing Sonic on his Fire tablet, and he's able to do it. And every time he asks me to help him, I'm like, I can't use this touchscreen for Sonic the Hedgehog. Like, doesn't compute. I'm like, let's hook up a game controller and make it work. But for something like this, where you're just simply going through and exploring and walking around the world and just taking your time, it works really well. It's also good for when you're like on the train and you're not really doing a lot of, you don't have to pay attention that much. You just need to walk around, explore, and you can actually get something done. Dreamcast had this vision that you'd have this memory card, and the memory card had a screen built into it with a little D-pad and the buttons. It was like, take your game on the go, and 1-bit, whatever that screen was. It was terrible. And it became this like Tamagotchi thing. But in this, you can actually take it on the go and play it on your phone, and then when you come back, maybe doing something like building, where you want to build something way more complex. I never built anything this complex. I just build like a box just to survive. I don't like, it's like I have a job. I don't need to like build out this elaborate house. I'm not an architect. But when you, like this, I may not want to do on a touch screen, right? I may want to use a mouse for it because it's a little bit easier to set it all up. Some of these are like really crazy. And then you get to fighting, and there's no way I would ever do this on a touch screen. I mean, you can, right? But I'd rather have a controller, because that's just sort of how my brain works. So fighting, which gets incredibly complicated, and there's a lot going on the screen at any given time. So then I can come home, and I can put it on a Fire TV, and everything's synced. So I just throw it on Fire TV and just play it on my couch, right? And now this one game has transformed itself across each device. I mean, I could just sit and play it on one device solely and enjoy that experience, but because you have customers who are playing your game and they want to take the game with them, if you got them truly addicted to a game, let them play the game however and whenever they want. And like I said, everything is, the best part of what makes their game work is that all the data is synced. There's no way this game could ever be successful across multiple platforms if you had to rebuild it every single time you went into a different platform. So we'll just sort of wrap up, and we'll talk about how do we reach more screens. So this is a blog post I did that goes into a lot more depth about responsive game design. A lot of the stuff I covered here is in there, but if you like to read, you can read it as well. And then that being said, I'll just throw this slide up. If everyone can give me an awesome review, that'd be great. You can give me a really bad one too. That's great too, as long as you tell me why. And it's like, this wasn't technical enough. Sucks. Like, real feedback helps. What's going to happen is, so in this room, we're going to start the next